So hi guys, welcome to my channel. So today I'll be solving this GFG problem of the day, which is majority vote. So again, the difficulty is medium, and but the accuracy is pretty good, like 48%. Okay, so let's read the problem and try to approach this. Okay, so you are given an array of integers nums where each number represents a vote to a candidate, means every number which is in the nums array represents the vote which is given to a particular candidate, means fifth candidate got one vote, fifth candidate got one vote, second candidate got one vote, and first candidate got one vote. Okay, so now return the candidates that have votes greater than one third of the total votes, means the total votes are 1 2 3 4 5 6 7 8 9 10 11 votes. Okay, so we have to return the candidates that got votes greater than 11 by 3. Okay, so if there is not a majority vote, it means that return -1. Okay, so we have to find the candidates who are in majority. Okay, so let's see with test cases. Okay, so now if we are standing on this particular index, what it tells, okay, so if we are standing at this particular index, then it means that this particular candidate got one vote, this particular candidate got one vote, this got one vote, and so on. Okay, so what we are going to do in approach 1 is, so let's make it like the person 2 got one vote, the person 1 got one vote, and the person 5 got 4 vote, person 5 got 4 vote, person 6 got 5 vote, as we can see clearly, like person 6 got 5 vote, person 5 got 4 vote, and person 2 got 1 vote, person 1 got 1 vote. Okay, so we have to find the majority. What are the candidates who are in majority? So how we are finding the majority means, what are the total votes is 11 divided by 3, which is somewhere around 3 point something, but we have to take the floor value, so we'll be taking the 3. So now it's very clear that all the candidates who get the number of votes which is greater than 3, that will be in majority. Okay, so here we can see that the count is 4, the count is 5. Now what are the candidates? Candidate is 5, candidate is 6, so simply we can see that the candidate is 5 and the candidate is 6, so we have found the answer. Okay, so in approach 1, what we are going to do is, whatever I have explained to solve this problem is approach 1. Okay, so I can make a map, and what I can do, okay, so I got a candidate 2 and I'll be incrementing the value. Okay, so I have done, means I have incremented the value corresponding to 2, which is equal to 1. Now I have got new candidate 1, increment the value to 1. Okay, got new candidate 5, increment the value to 1. Okay, again got 5, then increment the value, again 5, increment the value, so it will become 4. And for 6, do the same thing which we have done for candidate like above candidates. Now calculate the n by 3 and finally see that, okay, so make a loop in the map and check that whatever number which is greater than this number, so push it in our answer and finally return it. Okay, so 5 is the candidate whose like number of votes is greater than the majority count which we have calculated. Okay, and similar to 6. So this is how approach 1 works, but it will not be submitted because there is a catch in this problem. Like, we can solve this problem with this approach, but the thing is that in the question it is not clearly mentioned that what is the order of candidates we have to return. Okay, so whether 5 or 6 we have to return, or 6 or 5 we have to return. Okay, so like in this problem I have done the same, like I have created a map. Okay, initialized a n to the size, like iterating the number of elements in the num vector, and nums of I plus plus, means whenever I got a new element, I'll be like checking in the map and doing plus plus. Okay, so then initializing an answer vector. Okay, now iterating in the map and checking that it dot second, means this I have considered it as it while looping. Okay, it dot first, it dot second, means if it dot second is greater than n by 3, then push it in the answer and finally return. Okay, so one more thing to check, that if answer dot size is double equal to 0, it means that answer is empty, means no candidate got the majority vote. Okay, then simply return -1, otherwise returns answer. This works perfectly fine, but this still gives us the wrong answer. Why? Because like we don't know the order of, okay, so let me submit it. It will give the wrong answer, and you all can see that our output is 9294 and 9296. Okay, it's our output and their output is 9296, which is like same as our output, and 9294. Okay, you all can see, but the order is different, so we don't know, like it's not mentioned in the question. So let's move to second approach, which is the algorithm. Okay, majority vote. So now we have to see the second approach of solving this problem, which is Murray's voting algorithm. Okay, so before seeing this algorithm, tell me one thing, that in the question it is given that you have to find the candidates who got the votes greater than one third of the total votes. Okay, so if it is given that half of the total votes, means in the question it is given that 1/3 of the total votes. If in the question it is given that 1/2 of the total votes, then how we'll be calculating? Okay, so before that, tell me one thing. Okay, if we want to find the number of candidates who got the votes which is greater than n/2, okay, then how we are going to solve this? Okay, so we can see that the candidate 1 got 3 vote and candidate 2 got 3 vote. Okay, so let's just write it. 1 got 3 vote and 2 got 3 vote. Okay, done. Now if we want to find the number of candidates who got the votes greater than n/2, in this case what is n/2, which is equal to 6/2, which is equal to 3. So is there any candidate whose vote is greater than n/2? Okay, no, this is also not, because this is equal to 3 and this is equal to 3, but we want to find the candidate whose vote is greater than 3, means 4. There is no candidate present. Okay, so -1. Okay, so now let me do one thing, just remove it and make it to 2. Now there will be changes here. Okay, 2 got 4 vote and 1 got 2 vote. Now we can say that 2 is the desired candidate who got the majority vote. Okay, so if we want to find the candidates whose vote is greater than n/2, then there will be, then in the best case it will be possible that there is only one candidate whose vote is greater than n/2. So in conclusion, I can say that if I want the number of candidates who got the votes greater than n/2, n/2 means half. So there is only one possibility that only one candidate can get the votes which is greater than half, because half is this and half is this. If we expand it, so it will take some elements and get converged in this one. Okay, so it will get reduced obviously. So in the best case, it is possible that for n/2 there is only one majority candidate possible. It might be that there is no candidate who got the vote greater than n/2. We can see with this test case. Okay, so one candidate got 3 votes, two candidate got 3 votes, no candidate got the vote which is greater than n/2. So there can be like 0 or 1, but in the best case there cannot be more than one candidate who got the majority vote. Now let's come to n/3. So now let's take the case for n/3. In this case n/3 means 3, 3, 6, 3, 9, which is equals to 9/3, which is equals to 3. So whatever candidates whose vote is greater than 3, which is which can be like 4, 5, 6, anything, can be considered as the majority candidate. Okay, so let's count it. So candidate 1 got 3 votes, candidate 2 got 3 votes, candidate 3 got 3 votes. So is there any candidate who got the majority vote? No, there is no candidate. If I want to, this is candidate 2. Okay, so let me mark it with white. This is candidate 2, this is candidate 3, this is candidate 1. So if I want candidate 2 to get the majority vote, then I should have taken the one of the votes from 3. Okay, so let me make it to 2. Okay, so if I make it to 2, then candidate 2 gets 4 vote. Okay, this get the majority vote. Okay, this candidate got the majority vote now. Okay, so now we have one candidate. Okay, so if I want the candidate 1 to be the majority, then again I have to take the one vote from 3. Okay, so make it to 1. Now 1 becomes 4. The number of votes candidate 1 get is 4. Okay, so now one thing to be noticed here is whatever candidates vote I am taking to make the majority candidates, like 3, whatever votes 3 is getting is reduced. Means what I am trying to say is in n by 3, the total possible candidates who got the majority vote should maximum be 2. So what I have told here is we have two candidates who got the majority vote, but in three votes we have to reduce 2 votes. Okay, so it got 1. So in the best case, it is possible that only 2 majority candidate can get the votes which is greater than n by 3. Okay, so let me write it. So for n by 3, we can say that only 2 majority. So for n by 3, we can say that only 2 majority candidate, like best possible scenario is only 2 candidates can get the majority vote. It will never happen that like 3 candidates is getting the majority vote. Why? Because let's say one got 3 vote, 2 got 3 votes, and if I write 3 and then 3, okay, so 3 got 3 vote. So no candidate got the majority vote because all have the 3 votes. If we want to increase the count of votes, then we have to reduce someone's count. Okay, so if I want to increase and want to give votes to 3, then I have to reduce like one's vote and give it to 3. Now one's vote reduces, so the vote becomes 2. Now 3's vote becomes 4. So they got the majority vote. So in best case scenario, only 2 candidates can get the majority vote. Okay, so now conclusion time. So for n by k, if we want to find the candidates who got the majority votes which is greater than n by k, then in best case only k minus 1 candidate is possible. Okay, so now let's come to question. If we have to find the 1/3 of the total votes, then it means that 1/3 of the total votes means they are asking about n by 3. Then only 2 candidates are possible. In best case, only 2 candidates are possible. Okay, done. Now let's move to the algorithm or like the steps we are following to solve this problem. Okay, so now we can see the test case and finally see the how this Moore's voting algorithm works. Okay, so if we have to find for n by 3, that means the number of votes which is given is 11. Okay, so 11 by 3, which is equals to 3. Okay, so floor value we have taken. So now we have to find whatever elements or whatever candidate who got the number of votes greater than 3, that will be considered as the candidate who got the majority vote. Okay, so now so for n by 3, what I have told you is possibility of candidates to get the majority vote can be equal to 2 in the best case. So let's make 2 variable, which is majority 1 and majority 2. Now let's make another variable which is count 1 and count. Just see very carefully, after performing the iteration, you all will be very clear how this Moore's voting algorithm is working. So let's iterate. Okay, so now if we are standing on 2, means for majority 1, take the initial element which is array of 0 or votes of 0, 2, majority 2 also 2, and finally we'll be calculating the answer. Okay, so for 2, this is the best case. Okay, 2 can be the possible. If we are standing at 2, okay, our majority element matches with this. Okay, so we are standing at this element and the current person is giving vote to the second candidate. Okay, second candidate is our majority candidate. Okay, so let's increment our count 1. Now move to 1. Okay, so whether 1 is the majority candidate? No, initially it was 0 and count 1 was also 0. Okay, so now 1 is the majority 1 candidate? No. 1 is the majority 2 candidate? No. And the count of 2 is 0. It means that we can remove the majority 2 element and make the 1 as the majority candidate and make the count 2 as 1 because he got 1 vote. Now let's move to 5. Okay, so is 5 the majority 1 candidate? No. Majority 2 candidate? No. Then we will be removing or we will be decrementing the both count. So now you all will be wondering that why we are removing the why we are decrementing the count. So let me tell you the reason why we are decrementing the count of both the majority elements. Why? Okay, so when we see an element that doesn't match the current candidate, so our current candidate is this and this. If we see an element that doesn't match the current candidate, it suggests that the current candidate's potential, means this and this current candidate's potential to be the majority, may be decreasing. Okay, so we found an element which doesn't match with the current potentials element, current majority element, then the potential to be the current majority element should be decreases. It means that reducing the count of both the elements acknowledges that the current candidate is competing against another element. Okay, so let me repeat it once more because it is very important. So if I am reducing the count of majority element like this one and this one, it tells that the current candidate is competing, current candidates is competing with this element. Okay, this element. Okay, so to conclude, I get 5. Okay, so 5 is not the majority 1, 5 is not the majority 2, so 5 is competing with these two. So let's reduce the count of these two elements because there is one candidate who got the like vote, so just remove it. Okay, reduce it. Okay, so let's move our iteration. Now we move to 5. Okay, so now we are standing at 5. Okay, so whenever we get the count as 0, it means that we have to update the majority element as the current element. Okay, so now let's update it. It will become 5. Okay, and the count will become 1. Done. Now let's move to next index. Okay, so while we are standing on 5, we'll be checking that, okay, is 5 the current majority element? Yes, 5 is the current majority element. Then increase the count to 2. Now move it to next index. Okay, then again checking, okay, 5 got the 5 is the majority element. Yes, 5 is the majority element. Then increase the count to 3. Now let's move it to next index. Okay, 6 is the majority 1 element? No. 6 is the majority 2 element? No. But the count for majority 2 element is 0. It means that's not able to compete with 6. Okay, so let's remove this like 1 and make 6 as the majority element. 6 and increase the count to 1. Now let's move further. Now 6 is 6 the majority 1 element? No. Is 6 the majority 2 element? Yes. So increase the count to 2. Now move further. Is 6 the majority 1 element? No. Majority 2? Yes. Count the 2 further, means increment it 3. Now let's move it to this. Is 6 the majority 1? No. Majority 2? Yes. Increment 4. Similarly for this, it will be 5. Similarly for this, it will be 6. Okay, so now what will be seeing that at the end of the for loop, or like at the end of the iteration, the majority 1 variable will contain the first element and majority 2 will contain the second element. Now we have to do a validity check that we are going to find the frequency of this element and this element, and finally checking that whether whatever candidate we have calculated in majority 1 and majority 2, is it like really they are the deserving candidate. Okay, so we have to check a validity. Okay, so now let's count it. So frequency of 5 is equals to 4 and frequency of 6 is equals to 6. Okay, so now we can say that, okay, so 5 is greater than 3. Now we'll be pushing it in our answer. Okay, so answer will contain 5. Okay, so now 6 count is greater than like 3. Okay, so push it in our answer and finally return our answer. Okay, so now tell me one thing, that whether the answer vector size can be greater than equal to 2. So no, because for n by 3 only two possible candidates, like two candidates are possible who can get the majority vote. I have explained you above. Now let me write the steps whatever we are following. So this is the steps which we are going to follow, and let's see the steps and like dry run in one another test case and like whether we will be able to find it or not. Okay, so what are the number of elements we have? Okay, 1 2 3 4 5 6 7 8 9. Okay, so n is equals to 9 and we have to find that whether there is any candidate who got the votes greater than n by 3. Okay, so n by 3, 9 by 3, which is equals to 3. So is there any candidate who got the votes greater than 3? So let's check it. Okay, so initially what we are going to do, we'll be considering 1 as the majority element 1 and 1 as the majority element 2. like the first element of the vote. Okay, so now let's see. Okay, so let's iterate. So if we are standing at 1, okay, so what we are doing, if current element, okay, so let's see the steps. If current element matches with majority 1, means if current element matches with majority 1, then what we are doing count plus plus. Okay, so increase the count, okay. So now let's move to next iteration. Okay, so by the way, this is if, else if, else if, else if, and else. Okay, so now let's move to like next iteration. Okay, so we are standing at 1. Okay, so again, if current element matches with majority 1, okay, so 1 matches with 1. Okay, so increase the count, it will become 2. Now move to next iteration. Okay, again 1. If current element matches with majority 1, okay, it matches, increase the count to 3. Now come to next element. Okay, so this person has given vote to second candidate. Now if current element matches with majority 1, okay, current element matches with majority 1, no, comes to else if current element matches with majority 2, okay, current element matches with majority 2, no, else if count 1 double equal to 0, okay, check, count 1 double equal to 0, no, okay, so count 2 double equal to 0, count 2 double equal to 0, yes. So what we have to do, we have to assign majority 2 as current element and doing count 2 as 1. Okay, so let's assign majority 2 as 2 and count as 1. Okay, so till here it is like okay, clear. Now so 2, and next move to let's move to next index. Okay, so 2 now is, if current element matches with majority 1, okay, so 2 matches with majority 1, no, 2 matches with majority 2, yes, so increase the count. Okay, so increase the count to 2. Now let's move to third. Okay, so if 3 matches with majority 1, no, if 3 matches to majority 2, no, if count 1 double equal to 0, no, if count 2 double equal to 0, no, then we'll be coming to else statement and we'll be doing that count 1 minus minus and count 2 minus minus. Okay, so it will become 2 and it will become 1. Now let me tell you one thing again, which I've already repeated, but let me tell you, when we see an element that doesn't match the current candidate, okay, an element that doesn't match the current candidates, okay, it suggests that the current candidate's potential to be the majority may be decreasing. Okay, so this is the first point. Okay, the second point is reducing the count. Okay, reducing the count of both acknowledges that the current candidate is competing with the this one, the current majority candidate is competing with this current candidate. Okay, so that's why we have reduced it. Now let's move to next 3. Okay, so next 3 is 3 matches with majority 1 element, no, majority 2 element, no, then again we'll be reducing the count. Okay, it becomes 1, it becomes 0. Now move to next element. Okay, 3 matches with majority 1, no, 3 matches with majority 2, no, is count 1 double equal to 0, no, count 2 double equal to 0, yes. So we can replace the majority 2 as 3 and make the count as 1. Okay, so now let's move to next element. Okay, so this person has given vote to third candidate. Okay, so is 3 matching with majority 1, no, 3 matching with majority 2, yes, so we'll be increasing the count to 2. Now our iteration gets over. Now finally the candidate who got the majority vote is stored in majority 1 and majority 2. Now we have to check the final check by calculating the count of elements. Okay, so frequency, let's calculate the frequency of only 2 elements, like majority elements which we have calculated. Okay, so calculate the frequency of 1. Okay, so 1 frequency is 1, 2 and 3. So let's write it. 1's frequency is 3. Now 3's frequency, okay, so 1, 2, 3 and then 4. Okay, so 3's frequency is 4. Okay, so after calculating the frequency, if the frequency is greater than this number, then only we will be pushing it in our answer. Okay, so answer's best case scenario is 2 element. Okay, but is 3 is greater than 3? No. Is 4 is greater than 3? Yes. So our possible candidate is 3. Okay, so and then finally we'll be returning our answer. So here is the code. So what I have done is, initialized a count 1 variable to 0, okay, count 2 as 0, so initialized a majority 1 which is equals to first element of nums, and majority 2 also first element of nums, and an n which is equal to the size of the element. Okay, so now what I have told you is, first what I'm doing, checking that the current element means this current element. By the way, I'm running a for loop in nums. Okay, so if the current element is equals to majority 1, okay, in this case 1 double equal to 1, then we'll be doing count 1 plus plus. Okay, else if current element is equals to majority 2, okay, then doing count 2 plus plus means majority 2 count we are increasing. Now what we are checking, that if this condition fails, then we'll be checking that whether there is a possibility to make the current element as majority. Okay, so how it is possible? If any of the count becomes 0, okay, so we'll be checking that count 1, if count 1 becomes 0, then we'll assign majority 1 as current element. Now like increasing the count, because count 1 is 0, now majority element is the current element, and increasing the count 1. Okay, same doing, if count 1 is not equal to 0 but count 2 is equal to 0, then majority 2 is equals to nums of I, means current element, and like initializing the count 2 as 1. Okay, now if all the condition fails, it means that current like element has the power to become the majority element, then reduce the both majority elements count. Okay, so after like coming out of this for loop, the majority element 1 and majority element 2 stores the possible candidates. I'm not saying that they are the only like candidates, because we have seen here after storing 1 and 3, the frequency of 1 is not greater than 3, so we are not going to store it in our answer. So this is the validation step. Okay, so what we are doing, we have initialized an answer variable, answer vector. Okay, so initializing frequency 1 and frequency 2. Okay, done. Now running a for loop and finally calculating the frequency. If nums of I double equal to majority 1, increase the frequency. Nums of I equal to majority 2, then increase the frequency 2. Okay, finally calculating that if frequency 1 is greater than n by 3, simply push it in our answer. If frequency 2 is greater than n by 3, simply push it in the answer. Now finally check that if answer dot size double equal to 0 for this test case, okay, then simply return -1 or else return the answer. Okay, so let's see our test case. Okay, 1 1 1 2 2 4 3 1 1 1 2 2. Okay, so this is the test case which we have run, and I hope the answer for this will be 3. Okay, so let's see. So you all can see that the answer is 3. So let's compile it. Let's run. We have run. Let's submit it. Okay, so okay, so we have passed all the test cases. And what is the time complexity for this problem? Okay, so you all can see that okay, so you all can see that means this is a simple linear loop, means big of n, and here also linear, so big of n. And okay, so the time complexity for this problem is big of n. For the space complexity, it will be big of 1, because we can solve this problem by using 2 variables also, but on the safer side I have used this like answer vector. So initially, like eventually its space complexity should have been like big of 1, because we know like what is the maximum space it could take. So like 2% can be the like majority candidate, so we could have solved this problem using only 2 variables, but I have used this answer vector. But we have solved this problem in space complexity as big of 1 and time complexity as big of n. So this is how we are solving this problem. So thank you for watching and having patience. So thank you.